So what are you doing when your power goes out? My servers, they're still running. And when my batteries finally get low, every machine in my cluster just shuts itself down cleanly. There's no data loss, no corruption. Here, come check out what I built. Where I live in Calgary, it can get really cold. And sometimes that means that the power turns off from unexpected reasons. So we can't really have that. There's also some huge thunderstorms, and coming up on summer right now, it's looking like we're gonna have some big ones. It gets really hot during the day, and then all of a sudden 5 or 6 o'clock rolls around and we have some huge thunderstorms. They're beautiful, but also scary. I needed some way to protect my home server and my computer and just everything else that I have in my office. This solution is under $130. It took me less than an hour and everything's back up and running, and I don't have to worry about power surges or outages anymore. Let me show you exactly what I did. So what is a UPS? A UPS is an uninterruptible power supply. It's basically an external battery safeguard. It protects your system from irregular voltage, whether it be undervolting if you have something turn on like an oven, AC, or something like that, or from overvoltage if you have an electrical storm or something like that happen. It's basically a fail-safe, and it's a great thing for expensive electronics like PCs, my home lab, 3D printers, things like that. On the back of these UPSs, we've got a lot of different inputs and outputs. Now with this specific model, I've got some that are only on the battery. I've got some that are just surge protected. I've also got some Ethernet jacks. Now these are just more for communication so that I can plug it into my home lab. We'll get into that later. You'll see how we can shut everything down safely. Now you can buy them new. They run about $250 to $300 Canadian, or you can do what I did and chance it and try to find some on Marketplace. I found some used ones for $40. Usually the only thing that's wrong with them is the battery's dead on them. So why not just replace the battery? It's a consumable part. They're not too expensive. It just takes a little bit of know-how. So let's go ahead and do that. Okay, so the first thing that we actually want to do, make sure that we don't have this thing plugged in. It is a massive battery and charger, so we want to make sure that we have power disconnected. Now, this one is, I believe, like 10 years old. So let's go take a look and see what the battery looks like. So just on the underside here, there is a compartment that opens just like that. And then you can see we've got 2 batteries right here. Now, we'll just have to pull these out. So this is actually 2 batteries. These batteries are 9 amps and 12 volts. Now, it looks like there's just a little connecting plate here that connects both of them together. So we're gonna have to get that connection plate out to get our replacement batteries in. So let's go grab those replacement batteries and we'll just see kind of what they look like, because I don't know if you can see that, but these batteries are a little bit rounded when they shouldn't be. So these are the 2 new batteries I've got. And as you can see, they're roughly the same size. And these ones do not have a bunch of bulging on them. Now we have our new batteries versus our old batteries. Let's get this connecting plate off. And there we go. So it's just 2 new batteries, just like that, and we'll be off to the races. Before we finish up with this battery replacement, make sure you guys drop a like, comment, and subscribe. I really appreciate it, guys. It helps out a lot. Okay, let's get back to it. Black to black, red to red. And then we'll do the same thing on the other side here. Right out. All right, and then same thing with this one. Red to red, and black to black. Okay, I'll just put that back on like that. Now you can see with these guys that they were quite wide. They've bulged out. Now that's the sign of a failed battery. Let's get some tape for these. Okay, now that we've got the battery all put back together, these are the new batteries with the old housing. We can go ahead and reinstall this like this. Slide our cover back on. And now we can see we've actually got full bars on our battery now. So this is actually great. This is unreal because now I don't have to worry about my server just abruptly turning off and possibly losing precious data of mine. Now that the new battery's installed and it's all working properly, there's just one thing left to do. And that's use this RJ50 by USB connector to connect the UPS to the home lab. What this will do is it'll allow the home lab to automatically read what the power levels are in the UPS and turn off everything accordingly, but in a safe manner instead of just automatically turning off.
So the UPS is running, but right now it's just a battery with no brains. If the power goes out and the battery dies, everything still crashes. I need the UPS to talk to my network so my machines know when to shut down. That's where the nut comes in. Network UPS tool. It's free and it's open source, and it lets the UPS protect every machine on your network that's connected to it. First, I need to install NUT on pfSense. If you're running pfSense, this is easy. Just go to System, Package Manager, search for NUT, and install it. It's 2 clicks. Once it's installed, go to Services, UPS, and configure it. Give your UPS a name. I called mine Home Lab APC. Set the drivers to USB HID. That works for most APC units. Set the port to auto, and pfSense will find the UPS on the USB cable automatically. The important one here is the listen address. By default, it's set to localhost, which means only pfSense itself can see the UPS. I need my Proxmox server to connect to, so I set this up on pfSense's LAN IP, or just 0000, to allow connections from any machine on the network. If you skip these steps, nothing will be able to reach your UPS. That's the #1 mistake some people make. Save that, and now we can check the UPS status page. If everything's working, you'll see live data from the UPS. Battery charge, input, voltage, load, estimated runtime. Mine's running at 100% right now. It's great seeing this. That's pfSense done. Let's get on to the Proxmox side. On the Proxmox side, you install NUT as a client and point it at pfSense. Once it's connected, this node can see everything. Battery level, load, runtime status, all coming through your network. When pfSense says the battery is low, Proxmox shuts itself down automatically. I'm not going to link the full walkthrough for every config file here. Instead, what I'll do is link a guide in the description that covers the full Proxmox NUT setup. It goes through step by step. It's the one I followed and it covers pretty much everything. The short version, install NUT, set it to client mode, point it at your NUT server's IP, set a shutdown command, and that's it. And now the last step is to install NUT on Home Assistant. It installs just like any other package since it's supported. You just have to point it at the right port and pfSense's IP. And now that I've got a dashboard card showing everything, battery level, input voltage, load, status, I can check it on my phone. I can even see everything from my cameras too. It's great having everything in one spot.
Now that I've got the batteries replaced, the home lab all set up with the network UPS tool, there's only one thing left to do, actually test this thing out. I've got a display up here, and that's just gonna be running so that you guys can see it actually shut down properly. And it's only running on a 2-minute timer, that way we're not sitting here forever. So let's get to it. And just like that, we can still hear the UPS beeping and everything's turned off safely. So just to recap how much it cost me to protect my home lab and PC and everything. $30 to $40 for the UPS and then $40 each for the batteries. So right now we're up to $110, $120 and then $5 to $15 depending on where you can get an RJ50 to USB cable. So all in all, I'd say we're coming out pretty far ahead to make sure that our entire home lab is protected. Some of the stuff that we do here, make sure that we're protecting equipment and our home even when we're not around. Next video is going to be something similar, but we're going to be protecting a house from water automatically, so it doesn't matter if you're home or not. So make sure you be on the lookout for that one. If you want to check out the home lab video, it was the first video and it's where we all got started. All right guys, we'll catch you in the next one. Don't forget to like, comment, and subscribe. See ya.